Anyway.
Okay, we are gonna start and we're gonna try to fly through this fast because
I know that the screen said it.
nobody noticed on the schedule, we get tipped 5 minutes before $4. No. I know,
What?
we only have 40 minutes, not 45.
That's bogus.
I know. Okay, anyway, so today, we are still applying the power rule, but we're looking at more complicated power functions. I think the ones we looked at yesterday in the topic questions are pretty complicated with the square roots and the cube roots and the fourth roots and subtracting one from fractions. Okay, so, but it's more on those lines. So we know we've got these derivatives right now that we use for polynomials. This is the constant rule, this is the power rule, and this power rule. You have to have it written as x to a power. So can't have any x's in the denominator. Can't see any radical square root or cube root signs. We gotta rewrite it so we can see that power. Feel the power. Okay, so I say slope, you think?
Derivative.
Yay! Okay, you learned that expressions often need to be rewritten to see the power. So for instance, cubed root is written as x to what power? X to the 1/3. Okay, now that I have it written as a power, I can differentiate that. Okay, I can bring down the 1/3, write x, and then subtract 1 from the power. Right, so doing that on the board, I can bring down if f of x is cube root of x, and we've done our rewrite. No calculus there, it's just a rewrite. Then we can find our derivative. We bring down 1/3 and multiply it times 1. Exciting. Okay, but now we gotta find our new power. What is our new power?
Negative 2/3.
Negative 2/3. So the question is, how do we think about that? How do we navigate that in our brain? So I drew my brain for a couple of you yesterday. Right, here's my brain. And I'm thinking, I have to subtract 1. I have to subtract 1. And in my brain, I don't think of 1. I think of
3.
Exactly. It's so far away. I think of 1 as 3/3. And then that makes it easy to subtract the tops. Okay, so 1 take away 3 is -2. That denominator. And get it. Okay. So quick rewrite, 5 over x to the 4th is 5 times x to the what power? -4, exactly, right? Because it's downstairs, it's in the denominator. We need to bring it up into the numerator so we can get it in this form. 5x to a power. Okay, now we can do our calculus. So we bring down the -4. What does that make the coefficient? -20, right? -4 times 5, -20x. And then I told people to look at the number line. What is 1 less than -4? And then on multiple choices, you will never see negative powers, so you will see that. Okay. Let's see, what's my last tricky one? Whoa. Does the 2 come up top? No, right? This 2 stays right where it is because it's just the coefficient of the denominator. We got to make this into a power and bring it up top. What's the power on the x going to be? 4/3, right? We have a power of 4. There's my little counter. My power of 4 and a root of 3. Roots are like roots in a flower, right? They go in the ground, or they go in the denominator. It's kind of how I think about roots. Like the fraction bar is the earth, and the root then goes underneath. So we have 3/2 times x to the -4/3 because we brought it up top. then we can go and do that stuff. Okay. And then the last thing in the notes was dealing with questions symbolically. So like if we have g of x is 5 times f of x, then g prime of x is, if g of x is 5 times f of x, then g prime of x is what? Don't think too hard about it. There it is, 5 times f prime of x, right? 5 is just a constant, but then I have to differentiate this. Well, what's the notation for this derivative? F prime of x. And that's symbolic differentiation. In other words, it's seeing if you can use those derivative notations. That's up on the word wall next to the clock. Okay. So that's symbolic, and the symbolic questions are questions that you're going to be asked when you have tables and graphs, where you can go to f of 2 and look at the graph, and you'll see this nice line, and you'll go, oh, I see derivative, I think slope, so I'm going to go to f of 2 on the graph and find the slope of that line. There's your f prime of 2. Okay. So we generically say the derivative of f of x is f prime of x, exactly. Just really generically. That's why I said don't think too much about it. Just put the derivative notation on it. Drop the mic, walk away. Okay, so how do we apply the power rule for more complicated functions? The important thing is to get it in that form. Okay, that's really wordy, but get it into x to the n power. Maybe I should have just said that. Get it into x to the n power. Then perform power reducing process. Then do your power rule. Kind of like that better. These examples will kind of go away as we talk about different takeaways in the next class. This I won't. This won't go away. This will go away, and then we'll just keep building on this throughout the course of the unit. Okay, so this is a new experience for you. I have topic questions, which I expect you to do. But as we're working through these derivative rules, they're literally rules. They're like, you got to memorize them, right? You got to memorize what to do. It's a process. Bring the power down, get your new coefficient, multiply by the new power. You know, it is literally a process. So in addition to the topic questions, I have what's called a circuit. Those are optional. You don't have to do those. It's just extra practice if you feel like you need extra practice. They're self-correcting. Okay, so for instance, the first question in the circuit says find the derivative y prime of this function. Okay, so we see that we don't have an x to the n form of the function, so we have to do a rewrite. So do my rewrite here. What is this in its calculus form? Yeah. Exactly. 1/7 times x to the -2. Did you say 1/2? No, you said -2.
No, I think it's.
Okay, did you mean -2?
Yeah.
Yeah, because there's no root there. There's no radical. So, okay. Okay. So how about this one? How do we do a rewrite on this term? Yep. Yep, exactly, right? Because that's x to the first power. So it bringing it up to that's next to the -1. Now we can do our calculus. Okay, so this is a rewrite, not a calculus step. And then now we can do our calculus. Okay, and what we'll do is you'll get an answer if you are going to do the circuits. You'll get an answer, but you'll see an answer down in the box that's not the correct answer. You have to search all the other boxes to find the correct answer, and then that's the question you do next. And so it's kind of self-correcting that way. Like I said, these are optional. Okay, we'll do the topic questions. The topic questions are expected. The derivative circuit is optional. So at this point, go ahead and get into your topic questions. And don't forget your day 6 notes for Monday.
Yeah.
And you need your textbook.
If you're in the is indeed. Try to
And I don't have a separate box.